In this video, we're going to review Chapter 5, starting with the periodic table, which was developed by Dmitry Mendeleev. He came up with a periodic law. Previously, elements were ordered according to mass, but he ended up grouping them by similar recurring properties that recurred periodically. Next, we have Henry Moseley, who is the person who discovered the atomic number. Now, the periodic table has groups or families that are these vertical columns and horizontal periods that are rows. The periodic table can also be organized according to metals, nonmetals, and metalloids. The nonmetals are top right, and most of the elements are metals and they're lower and to the left. There's a staircase where there are the metalloids that contain properties of both metals and nonmetals. Metals are exactly what you think they are. Nonmetals are probably what you think they are as well. They can be solid, though they are also liquid and gas potentially. They're dull in luster, they're very brittle, and they are not conductors of electricity, whereas metals are the exact opposite. Metalloids are somewhere in the middle. They tend to be brittle, but they tend to look a bit metallic in terms of their shine, and they are kind of conductive. They're semiconductors. The periodic table can also be grouped into the S block, P block, D, and F block. The D block is known as the transition metals, the F block is the inner transition metals, and the S and P blocks are the main group elements. Group 1A, the alkali metals. They all have one valence electron. They are very, very reactive. They're the most metallic of the metals. They're very soft. You can usually cut them with a butter knife, and they're low in density. The alkaline earth metals are kind of like the alkali metals, but a little bit less metal. They are a little bit harder, for example. They're not quite as shiny, and they're denser. They also are still pretty reactive, but not quite as reactive as the alkali metals. Moving over, we have group 7A, the halogens. These are the most reactive of the nonmetals. They tend to be quite toxic and smell bad. They have different phases. As we can see, iodine is a solid, bromine's a liquid, chlorine and fluorine are gases. They are non-conductors because they are nonmetals. Next, we have group 8A elements, the noble gases, which are very chemically stable. They're completely inert, they're odorless and colorless. Moving on to periodic trends. We start with effective nuclear charge, otherwise known as ZEF. This is essentially the charge that the protons in the nucleus have, minus some shielding effect by the electrons. A valence electron will not feel the full charge of the nucleus. It will feel an effective nuclear charge that is diminished by the fact that there are electrons in the way that are shielding. Moving on, we have atomic radius. The lower you are and the further you are to the left on the periodic table, the bigger the atom. Next, we have ionization energy, which is the energy required to remove an electron. It is harder to remove an electron that's further to the right and higher up on the periodic table. We see this increase. Next, we have electronegativity, which is the ability of an atom to attract electrons in a chemical bond. Note that we don't really think of electronegativity when we talk about the noble gases because they're pretty much chemically inert, but as we move rightward and upward on the periodic table towards fluorine, we have a higher electronegativity because those atoms are really good at pulling in electrons. All the trends that we've seen as you go across a period, they're all explained by effective nuclear charge. If the effective nuclear charge is higher, it is harder to remove an electron because it's being pulled in more. Also, if the effective nuclear charge is higher, the valence electrons are pulled in more, resulting in the smaller atomic radius. Trends down a group, by contrast, they are explained by the number of shells. Although effective nuclear charge slightly increases as you go downward, atoms get bigger as you have more shells, and as the valence electrons get further away, they are less pulled in by the nucleus, thus explaining the vertical trend in ionization energy. Continuing on, we have metallic character. Metallic character trends with low ionization energy. As we look to the group 5, we know that nitrogen and phosphorus are nonmetals. Arsenic and antimony are metalloids, and bismuth is a metal. And just looking at the samples, they look a little bit more metallic as you go further down, and certainly they have, in general, more metallic properties. Moving on to reactivity. The most reactive metals are those that have a low ionization energy. Lithium has a higher ionization energy than does potassium, and that's why it only bubbles when it reacts with water. Potassium explodes, and rubidium and cesium make an even bigger explosion. Also, the most reactive nonmetals are those with higher electronegativity. So, for example, chlorine reacting with sodium explodes, but iodine, when reacting with sodium, creates a much more muted response because iodine has a lower electronegativity and chlorine a higher. What we see in general is that reactivity is greater as you go towards fluorine top right and towards francium bottom left. So that is all for this video. I hope it's been helpful. Feel free to leave any questions or comments in the comment section below, and thanks for watching.